Hey, today I was using this board for the demonstration, and we're checking some of the panes of this Roho component. Now I'm using the Planar City JIT, which is the platform. And now place this one straight to the center of the platform, then close the front door. Then the machine will start navigate itself. Okay. Then we go to the software, turn on the Xray, and use the navigate dots to navigate to the specific place. Then you will see the X-ray image like that. Now we need to figure out which part we need to scan. For example, if you want to check in the Xray component, you need to tilt the axis to see if there's any defect in the DR image. So we can tilt about 47 degrees, you can see here. Then zoom by using the X-ray button. So we'll see this one is not completely filled out, right? You can see there's still have the empty space. So we can use this part as our scanning object. So we can quickly use this one to return all axes back to 0. Then we navigate to the specific place, which is this one. Then we turn on the cross grade to do the alignment. Okay, and turn on the 3D scan function, 3D scan interface. We create a new profile like 2026 May-1, and we'll change the resolution right now to give a better. For example, the 8 macrons too close to the screen, so we'll change to like 10, maybe 15. This one's better. Then we choose the layers that we want to use for scanning. You should never use the layers that's less than 1000, so we'll change the default one. It's a 1536, or use the continuous not step. And the product height, I will define this one probably 2 millimeters, and the tilt angles, keep it 45 degrees. Then we can start scanning. Once you start, you will see the progress bar. And you can easily see the defect on the DR image which we're focusing on. Then after the scanning, we will see it directly in the 3D software. So I will pause the video because it will may need about 5 to 10 minutes about the scanning and the reconstruction. Okay. After the scanning process done, and you're able to see, you see this is the machine, and now we're back to the workstation machine, and you automatically open this profile that you scanned. We scanned before. Because we're using the planar CD method, so we have to fine tune a bit about the reconstruction parameter. So we're right click the volume 1, which we scan, reopen the CD's reconstruction, and go directly to geometry. Okay. Now, to open the slice preview to make sure every changes we do, then we can see the effect directly. Okay, something like that. Remove the layers to the specific layer that we can define if it's okay or not. See, now there's a bit of artifacts around the object that we scan, so we need to do some offset, make some offset. We'll first change the source director to a little closer, like 270. We'll give you reference value once you receive the machine. It may be 270, maybe 260, but it doesn't matter. The most important part is the horizontal detector offset and the vertical detector offset. So we can change the first one to see it. This one, not that much. We're trying the 0.1, maybe a bit bigger. Okay, then we can change the layer to see if our effect is okay or not. Like that. Okay, perfect. And then we change this one, 0.1 first. Okay, maybe bigger. Change the project skip to see the precision image. And 0 to no skip, which is the original image. And you see it's loading. Okay, you see there's still a bit offset on the vertical side, so we'll change to another direction. Now is 0.3, we can try the minus 0.3. It's still loading. Better than before, right? So change a bit. Smaller. Nothing happens. Try bigger. Even there. To see and which value will get the better quality of the image with no artifact, and it will be the better option that we can do the analysis. Okay, you see now it's much better, right? no any artifacts around. So which means this is the better parameter for the specific object for the sample. Then we can do the preview to see if it's good for us or not. So we uncheck the volume 1, just see the previous volume 2, and move the specific layers to the point, to the part. And also the blue part. So it's great. So then we reopen the reconstruction and replace it directly. So we will change the preview volume to the real volume. It takes time, but we're already dead. You see, it's changed from the preview volume to the real volume. Now we get the real volume, volume 2. Now the first thing we need to do is to go to the full screen side, and we're mainly focused on this one, right? Mainly focused on this one. So we're using the clipping box to clip all of the interference part out. Okay, done. We just keep the part that's the only part that we focusing on, and yeah, something like that. Okay. Then we can analyze them in different layers. But before we do the alignment, okay. Change the contrast, even change the contrast of the image. Now you can easily find the defect here, right? So this is the good one. This Xray is the good one, and you can see from different layers, you see compare with others. So in this case, we can mark them using the indicator. Rename them. I'm done. And you will see your indicators in different views. Okay, so now we back on talking about create the images, save images. We can add a 3D view here. And this part. Save. And even we can make animation. We're checking something. Then we need to open the clipping box to make it bigger to see the full view of the parts. Like this. Then lock the clipping box, change it back to the volume. Okay, now we're going through using the keyframer. So we do this as the first frame. Then we focusing a bit on this part, focusing a bit on this part, focusing on a bit on this part. Then we change the transparency to like 25 first. Then 50. Make another frame. Then 75. And rotate a bit to another angle, just see differently. To easily find the difference between the parts, part to parts. And then change back to 0 and make different color, smart color. Or using for example, this as a frame, move to here as a frame, then here as a frame. Then we can see change the FPS to like 60 and play. Okay, then we can save this rendering this one. Maybe AVI. THNG. Okay, let's start rendering. It takes time, so I'll pause the video. Then we can check the video that we made using the control panel to change speed to like 0.2. And then we talk about the measurement. We can turn off the keyframer, change back to solid. Now we turn back to this part, and then we use distance. Or even something like that. Or caliper. Okay. Then we can open the window, quad profile, to see directly in the histogram what the materials in different densities showing what. Like right now it's showing this part. So it's the center material to the age of the defects, and the size is 0.5 millimeter. And then we can make a save image by using those profiles and also your images. Like this. And also we can create a report, included the 3D service volume, only volume 2. The volume 1 is not what we wanted to do. Okay. Now we select the volume 2, create a report. We don't have a 3D service because this need a service dimension. Change the report to PHNG, and then create. And this is our report. Included all the measurements, alignment information, something like that. Component information, instrument table, for example, the indicator, the distance, the caliper that we were choosing, and you can add it. For example, add an image here, custom image, dynamic from the screen, from the views. Review. No data. Manufacturing information. No data. We can create something like that. Exit. So we can create a view, like this view. In the view, bookmark and view. This is the bookmark. If we move and go back to the place, for example, move, zoom out, double click, and we'll change back to that place. And we go back to our reports, we can add a bookmark. Nope. A custom image, for example, the image we saved. It should be PNG, JPEG, and GIF. Let's save a PNG file instead. Let's choose the PNG this time. Save. Go back to the report. Edit. Custom image. I can put it here. But we want this one not here in this instrument table. So we put the image here with the data. That would be much better. And let's log and save. You can export. I suggest you to export like an HTML, which will better for us to access. Like that, with our image. Okay, this is pretty much everything that I can show you guys in this video.